Hello everyone, welcome back to my YouTube channel. So on day 4 of Kubernetes series, today we are going to focus on replica sets and deployments. These are two main or important components of Kubernetes, and we generally deal with these objects on a day-to-day basis as well. So let's understand what is replica set and what is deployment. So before moving to replica sets and deployments, I have mentioned here one line why just a pod is not enough. Why we cannot directly use pod to deploy our applications. So when we deploy our application inside a pod or using a pod, we generally get a single instance of our application. So what if that pod uh, crashes, or maybe the node where the pod is running that goes down? In that case our application will also be down. So a single pod doesn't have few capabilities like self-healing, like if something goes wrong with that particular pod, or maybe it got crashed, then it will automatically create a new pod. But that is not the capability of single pod. So single pod cannot do a self-healing. Now another thing is scalability. Suppose if you are getting a lot of traffic on your applications and you are running a single instance or single pod for your application, in that case that pod cannot handle that much traffic. So, and the pod itself doesn't have the capabilities of scaling, like it can scale to a multiple instance. A pod can't do itself. So in all those to resolve all those issues, basically we generally use a replica sets and deployments. They basically completely manage our life cycles of our application, or we can say a pod. So they will basically automatically scale up or scale down our replicas based on the desired configurations. And deployment, again, it's basically like we cannot directly use a replica sets, we have to go through the deployment. So let's understand one by one what is replica set first, then we will move on to deployment. Okay, so what is a replica set? So we call this the pod watchdog. So a replica set makes sure a specific number of identical pods are always running. So you have to mention here one word, which is identicals. So replica sets basically or generally use when we have to create a identical pod. Suppose I want a 3 instance of my application pod always up and running. So that is the job of replica sets. So suppose in any of the cases, if one of the pod goes crash, then the replica set automatically create the new pod for us, because that is the capability of replica sets. So the job of replica sets to keep the desired number which we have specified in our configuration. So always based on the desired configuration, like if we have specified 2 3 4 whatever, so it always keep up and running those number of pods which we have specified. So that's what we have discussed. If the pod goes crash, or if pod crashes, it create a new one. If there are too many pods, it delete the extra one. It maintain the desired state basically. So whatever the configuration we have specified 2 3 4, based on that, because it looks for the configurations, how many replica sets we need for this instance accordingly. So this is the desire basically we have mentioned in the manifest file. So accordingly it will keep those number of identical pods up and running. What replica sets give you? High availabilities, because if something goes wrong with single pod, it will automatically create a new pod or replacement pod for that basically. So it is highly available. Scalability, you can increase or decrease the number of pods easily. What replica sets don't handle updates or rollback. That's where deployment are used. Suppose today I am using suppose 1.1 version of my applications. Now tomorrow I need to deploy another versions, maybe 1.2. Now if we have seen, okay, 1.2 have some issues, then we need to again rollback our application to the previous version. So that capabilities replica set doesn't have. So for that, basically we need to use a deployment. So basically this is the combination, like when we create a final manifest file for production uses, we generally involve so many objects in a single files to keep like high availability, scalabilities, and lot of things basically we keep in a single file. So that the complete manifest file we will see maybe couple in after couple of days once we reach to that level. But this is the basically whole purpose to why I'm going with one by one single one objects here, because I just want to demonstrate how the single objects works here. So we have discussed about replica sets. Now we will see a deployment. So deployment we call as a app manager. So a deployment is what you will mostly use in real world projects. It manages replica sets which then manage pods. So you can see a dependency here. Deployment is going to manage replica sets and replica sets is going to manage your pod. So you can think of deployment as the project manager. It knows how your app should run. It manages updates, scalings and rollbacks. It keeps everything smooth and controlled. What deployments offer? Declarative updates. Like you simply say I want version 2.0 and it will automatically handle everything for you. Rolling updates. Updates happen step by steps, like no downtime. So if you are going to roll out a new version of applications, so immediately it will not delete all the existing pods or it will not automatically update all the pods. It will do a one by one. First it will update one pods, then it will again, once that is up and running, then it will go and update another pods. So like that basically it does. So end user will not face any downtime. Self-healing. So it still relies on replica sets to replace broken pods. So this is the self-healing is a job of replica sets, because that's what we defined the numbers which the identicals, like how many identical pods we need, those configuration we defined under replica sets. Easy rollbacks. If you want to revert to a previous version, if something goes wrong, you can easily roll back to a previous version as well. So this is a job of deployment. So we have discussed two components, replica sets and deployment. Deployment is an app manager who is going to manage everything for you, and replica set is to keep your app up and running always. Okay, now let's move to a demonstration part. So we are going to follow day 4 series here, sorry, day 4 folder here. So I have created two separate files, one for deployment and another for replica sets. So first we will see replica sets configuration, how we create replica sets, how basically this life cycles of replica sets works. So what I will do, let me go to my Visual Studio. So I'm not going to write a code, I'm just going to copy it because it will I will save some times here. So let me open this file. This is very simple file, I will explain you. Let me copy the file name. So I will create a file with same name. Okay, now let me go and copy this complete code. Okay, so this is the API versions, like which API version we are going to use for this particular resources. So we are going to use API version which is app/b1. So there are different API versions for different kind, like for pod is different, service is different. So you have to always use a correct API version. Another thing, we are going to create a replica sets. So generally we do not create a replica set separately. It is a part of deployment template. But for this demonstration, I just want to show you how replica sets keeps your desired state or desired number of your pods which you specify. So API version kind, then another we have metadata. So here we define a name of our object which we are going to create. So this is the name of our replica sets, which is nginx-replica sets. And you can see under specification, I have defined here replicas colon 3. So I want 3 numbers of pod always up and running. So here we are going to use selectors. So we already discussed selectors, labels and selectors. So here I am going to selectors and match labels, and this is the name of our container basically. So if you can see under templates, so this is the template of our pod. So you can see we have combined here pod template, then we are using replica sets. So under template metadata I have used same labels because this replica sets will always match with this label. So this label name and match labels name should match. Like whatever you are going to group, that label you have to specify under selectors. And in under specification we have simply a few parameters, again containers, name of the containers, image which we are going to use as part of this demonstration, and port. So container port is 80. Okay, now let me save this file, and now let me clear the screen. Now let me apply this file, kubectl apply -f, and file name is ReplicaSets. Okay, what happened? kubectl apply -f. Oh, sorry, ReplicaSets. Okay, let me copy the name. Okay, ReplicaSet -nginx. Okay, actually this file is inside folder day 4. That's why it's not taking. So let me let me go inside the folder day 4. Let me clear the screen. Now let me run the command kubectl apply -f and file name which is ReplicaSets. Okay. So as soon as we run this command, let me clear the screen. If I'll search for kubectl get pods, so we will see 3 numbers of identical pods in our Kubernetes basically. So still the status is creating. So let's wait couple of minutes. Now let me rerun it. So now we can see all 3 pods are up and running. Now if I'll remove, or if I will delete this particular pod, let me copy it and let me run the command kubectl delete pod and pod name. As soon as I will delete this file, ReplicaSets automatically create a new pod or a replacement pod of this pod basically. So let me run this command first. Let me clear the screen. kubectl get pods -watch. So we will see what is happening here. So we have deleted a pod which name was which start from n. So we can see here we have the new name, like we have 3 pods. We have deleted 1 pods, but still we are seeing 3 pods up and running. So it means ReplicaSets is working fine because we have specified here we want 3 identical pod always up and running. This is the desired state which we want. So it is, as soon as in real world if something goes wrong with a single pod or maybe multiple pods, so ReplicaSets automatically created a replacement pod and we will not face any kind of downtime basically. So now let me close it and let me clear it. Let me go back to my GitHub documentation, and if I go to readme file, let me see if what. Okay, so we have discussed a self healing. So we have already we have deleted the pod and it is automatically created a new pod for us. Okay, now let me delete this file as well. Sorry, delete this deployment or ReplicaSets. So let me go here and run this. Okay, now if I'll run kubectl get pods, so we don't have any pods now. Okay, still we are able to see that's okay. So it takes some time because as soon as I run kubectl get pods, we have seen 2 pods. So it's already start deleting those pods. So now we don't have any pods in our default namespace. So now let me clear the screen. Now let me go and move on to deployment part. So let me go deployment.nginx YAML file. and let me copy this name. Okay, now again I will create a new file here, and let me copy the code as well. Okay, so again the API version, which is app/v1 K8s deployment, because now we are going to create a deployment. And you can see here the description also, we are getting deployments enables declarative updates for pods and replica sets. This is what we have discussed as well. Okay, so metadata, this is the name of our deployment, which is nginx deployment, and under specification I have specified we want 3 replicas, and under selectors we are going to match the same label which we have defined in a pod template, basically this one. So this is the same name you can see, and this is again a simple configuration. We are going to use 1.14.2 nginx image. So now let me save it. Now let me apply this file, kubectl apply -f, and file name is deployment dot. Okay, so if I'll go kubectl get pods, okay, so spelling mistake, let me correct it, kubectl get pods. So now we are getting 3 pods which is up and running. Now let me check a replica set, so we can simply type rs. This is the short form of replica set. So we have created a single replica sets, which is this one, and we can see the desired number, we want 3, and the current is 3 and ready is 3. So it means the replica set is also working fine. Now let me check again kubectl get deploy. So this is the deployment basically. So here this is the name of our deployment which we have created, nginx deployment, and status you can see 3 out of 3 is up to date and available. So it means it's working fine. Now we need to see a rollback and rolling update as well, because that's what this is the job of deployment. So now let me do one thing, let me clear the screen. Now what we will do, we will change the image name here. So this is 1.142, let me look for 1.15.2. so now what we are going to do, we are going to run a new version of our applications. Let me save this file. So now if I'll reapply this file, which is deployment, okay, and if I'll go and check the pods, kubectl get pods -watch, so you can see we have 3 pods up and running, and it is already started creating a container, which is, you can see the status 0 out of 1. It means it is still creating a replacement container basically. In case if this image version which I have just randomly specified, if it is not correct, maybe the deployment will fail, because it will not able to download or pull the image from the registry. So let's wait couple of seconds. Okay, I think it got stuck because containers is creating state we are getting here. So let me cancel this and let me run kubectl get pods. Okay, so still we are able to see containers creating, it's fine. Let me again put a watch flag. Okay, so you can see it is created 3 containers, and it is start terminating the old one. So it is not directly roll out the version which we have specified here to all the pods. First it will replace it is applied to a single pod. Once it's done and the pod is up and running, then it applied to the another pod. So like that it is completed. So if I'll cancel this, so now you can see all completed. If I'll cancel this now and let me clear the screen, if I run kubectl get pods, so now we can see we have 3 up and running pods. This is what we want because of the replicas which we specified here. Now we need to verify the version here. So what I will do, I will copy a pod name and we will use kubectl describe pod and pod name. So okay, so we need to verify a version here. So let me go and check. Okay, so you can see the image ID 1.152. So this is the version of our application which is running now. It means the function or the feature of deployment is rolling updates and rollback. So rolling update, we have seen it is applied this particular nginx image one by one to each pods, and once that pod is up and running, then it start applying to another pod. So it means it's working fine. Now let me clear the screen. Now we will see a function of the feature called rollout. So what we will do, let me change the version again. Let me keep 1.4 again. Let me save it. Now I will again run the command and we will watch it. So you can see when we did a rollout, it again applied the same procedures. So this is very simple. In case if something goes wrong with a version which you have deployed, then automatically we can roll out to a previous version. We just need to specify the version which we want. This is the public image which we are going to use, but in real world we generally use corporate images, like in-house images, basically Docker images. Okay, now let me cancel it and let me close it and clear it. kubectl get pods. So now we have 3 up and running pods. Let's verify the image version is as well. So let me copy the pod name, kubectl not get describe pod and pod name. So now we should see a version 1.14. So if I'll go to a image section, so we can see the version 1.14.2. So this is the rollout process basically. Okay, let me go to my GitHub documentation. Let me see if I missed anything to explain. So we have seen a rolling update, which is fine. Okay, we have not seen a rollout history. If I'll run it, let me see if we can see it now. So let me clear it and let me run this command, kubectl rollout history deployment, which is nginx deployment. So actually we are not able to see here revisions or changes caused because we have not because Kubernetes does not automatically save these changes. We have to specify through our annotations. So if I go back here, so you can see, you might notice a change cause and column says none. This is because Kubernetes does not automatically track why a changes was made. So that is your job. You have to specify what you have to do. You have to simply use the annotation under a metadata. So let me do it. So I'll go to metadata section. Here I will search for annotations and here let me copy the name. So the name was kubernetes.io/change cause, and this is the message basically we have to specify. So because when we are rolling out or when we are rolling back or reverting back, we have to specify the region. So at least we will have a track, okay, why we did, what was the region, so it will easy to other people as well. So let me put it here. Now what we are going to do, we are going to change this image to latest version. Okay, and updated nginx to latest stale version, or mention the version. So I'm going to use a latest. So this is the message basically we will see. And now let me go and save it. And what we will do now, we will apply the changes again. Let me go to apply. Okay, so again we will go kubectl get, sorry, get pods, and here watch flag. So now we will have a history of rollout. Okay, looks like it's completed. Let me clear it, clear the screen, and let me see kubectl get pods. Okay, again the commands kubectl get pods. Okay, so we have 3 pods up and running. Now we will run a rollout history command, which is rollout history. So here we can see a 4th revision because we already did 3 times. So this is the 4th time we are seeing a message updated nginx to latest stable version, or mention the version. This is the message basically it is displaying. So whenever we are doing a rollout or rollback, we have to specify a message or the version, on which version we are going to roll out. So Kubernetes will have a track of it, so it is easy to manage when what all the changes you are going to apply, or what all the versions you are going to roll out or roll back. So that's how you have to specify those messages. Okay, now let me go back. So now if you have to roll back to a previous version, what you have to do, you have to simply run rollout command. So if I'll run this command, so this is rolling update we have seen. Now if I run this command, so ideally we would see. Okay, let me cancel it, clear the screen as well. Okay, so let me copy the command again. Okay, so let's see under which version it is basically rollout. So I will go kubectl get pods. So still we can see containers is creating. Let me put a watch flag. Because last we have used a latest versions. So now when we see a log of our deployments or our pods, we will see any specific version. I think it was 1.14.2. We will verify it. So I think it's completed. Let me check kubectl get pods. Okay, now let me copy the pod name, kubectl describe pod and pod name. Okay, so let's verify the image ID here. Okay, so it was 1.142. So it is rollback to a previous version. Basically we did undo, we have directly run the undo command in simple words, if I would say. So that's how basically we can do a rolling updates, rollback to in real world also we will do a similar kind of things. So I think we have covered everything which was supposed to discuss as part of this particular video. So that's all for today. In case if you have any doubts, you can ping me over comments box. I will reply as soon as possible, and I will also mention the GitHub link in description box. So if you want to do hands-on with your own, you can do that. So thank you so much. See you on next video.